Hello students, in today's lecture we are going to discuss about extracting the metals in the low activity series. So how to extract the metals which are in the low in the activity series, this we already discussed in our previous lecture also. So they exist in the nature in the form of sulfides usually. So by heating procedure you can obtain the oxide of that particular metal. After getting the oxide of the metal, again if you supply heat, then the pure metal will be released. Coming to now extracting the metal in the middle of the activity series, how to obtain this one. So here two methods are there. What are they? Calcination process is one method, and another one is also presented here. So roasting. So you can do roasting and calcination. How we will do? Example with the zinc you are given here. Right? Usually how they exist, these middle activity series materials, they exist either in the sulfide form or carbonate forms. So first what you have to do, you have to give heat energy. You have to heat that. If it is in the sulfide form, here zinc sulfide is there. So here we are using this process is known as the roasting process. So sulfide ores are converted into oxides by heating strongly in the presence of excess air. This procedure is known as roasting. So if sulfide type of materials are heated in the air, that process is known as roasting process. If carbonate ores are changed into oxides by heating strongly in the limited air, this process is known as calcination. So here both cases we are giving heat, we are giving heat energy to that particular compound. If it is a carbonate form, then we are naming it as calcination. If it is in the sulfide form, we are naming it as roasting procedure. So initially first, whenever it is reacting with the oxygen, zinc sulfide is going to form zinc oxide and sulfur dioxide gas is getting released, and this process is known as roasting process. Now similarly in the calcination process, we are taking zinc carbonate and it is heated in the presence of air. Then zinc oxide is formed in the solid form and carbon dioxide gas is released. In the previous case, in the roasting process, sulfur dioxide gas is released. In the calcination process, carbon dioxide gas will be released. After getting the oxide, what we have to do? So the metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. So here the reducing agent is carbon. So when zinc oxide is heated with the carbon, it is reduced to metallic zinc. So zinc metal is coming here and carbon monoxide gas is getting released. So we already know the process of oxidation and reduction. What is known as oxidation? If a metal is getting reacted with the oxygen, we name it as oxidation. In the case of reduction, the material is going to lose its oxygen content. So then that is known as reduction process. So in this case, ZnO is getting reduced to form Za. So here it is a reduction process. So here you can use the this procedure, or sometimes we can use carbon to reduce the metal oxides to metal. Sometimes displacement reactions can also be used. The highly reactive metals such as sodium, calcium, aluminum are used as reducing agents. So that also you can. So here what is happening? They displace the metals of lower reactivity from their components. For example, here manganese oxide is taken, right, and it is heated with aluminium powder. The following reaction takes place. What is going to happen? Manganese is coming out and Al2O3 is formed in this, it is in the solid form and heat energy is getting released. So what is this substance that are getting oxidized and which are reduced? So manganese oxide is getting reduced and it is going to form manganese, and aluminium is getting oxidized to form Al2 O3 that you have to identify. And similarly in this Fe2O3 in the solid form really reacting with aluminium, then iron is getting released, and Al2O3 in the solid form it is going to form. So these displacement reactions are highly exothermic, you know this already. So they release so much of heat. So the amount of heat evolved is so large that the metals are produced in the molten state. Here you are going to get in the liquid form, you can observe. The manganese is in the liquid form and iron is also in the liquid or molten state. So whenever the reaction of iron oxide with aluminium is used to join railway tracks or cracked matching machine parts. Here in the picture you can see for attaching the railway parts, what is used? Iron oxide with aluminium. If they are used for joining the rail tracks or cracked machine parts, this reaction is known as the Thermit reaction. This, please remember this one, this is known as the Thermit reaction. So here what they are doing, they are using iron oxide, Fe2O3 will be in the solid form, that is getting reacting with the aluminium, and this will help to join the tracks. That is, here it is a practical application. Now coming to the extracting metals towards the top of the activity series. How to extract the metals which are very highly reactive or which are in the top of the activity series. So here you need to observe that in the previous cases what you did, we have taken sulfides of those metals or oxides or carbonates of those metals you are having the previous cases, and we heated them in the presence of air, and we obtained the oxides of them, and from that again we got the metals. But now in this case, if they are very highly reactive metals, you cannot go for that process. You have to go to the another process. Why? Because they cannot be obtained from their compounds by heating with the carbon. So they cannot reduce the oxides of sodium, magnesium, calcium, aluminum, etc. to the respective metals. Why? Because these metals have more affinity for oxygen than carbon. So in that case, what you have to do, you have to go for the electrolytic reduction. So what is electrolytic reduction? Okay, sodium, magnesium and calcium, all these metals, they will be obtained using this electrolysis process. We will take the molten form of their chlorides. The metals are whenever we do this electrolysis process, the metals will be deposited at the cathode, usually negatively charged electrode. Why? Because the metals will be positive ions, because they lose the electrons and they will be coming towards the cathode, whereas chloride is liberated at the anode, the positively charged electrode. So the reactions are at cathode Na plus, and at anode 2Cl minus will come and chlorine, like this. Similarly, aluminium is obtained by the electrolytic reduction of the aluminium oxide. So whenever you are having a highly reactive materials, metals, you have to go for the electrolysis process. Next, the process of refining of the metals. So till whatever we learnt is how to extract the metal. So we use different methods for extracting the metals, whether it is electrolysis process or carbonation or heating process. Different methods we used, roasting process, right? Whatever the method, the metals that are produced by various reduction processes, they are not very pure actually. So they contain impurities which must be removed to obtain the pure metals, is it not? So the most widely used method for refining the impure metals is electrolytic refining. So here it is shown in the figure. So electrolytic refining of copper we are doing here. So electrolyte is a solution of acidified copper sulfate. So here we are taking copper sulfate solution which is acidified, right? The anode is impure copper, whereas the cathode is a strip of pure copper. So see here, cathode is the strip of pure copper and anode is the impure copper. On passing electric current, pure copper is deposited at the cathode. Why this is happening, that we need to observe. Okay, solution of the metal salt is used as an electrolyte. Apparatus is set up like this. Pure metal. In this process, electrolytic refining, we use refining of metals like copper, zinc, gold, silver, etc. So as we are showing in that setup, we have a cathode and electrolyte. A solution of the metal salt we can take, for example copper sulfate, for extracting copper. For example, refining in the copper anode, at the anode you will get the impure copper, and at the cathode pure copper strip you can obtain. So acidified copper sulfate solution means copper sulfate together with H2SO4, like that you can take. So at anode, oxidation process takes place. So impure copper will be there, Cu2 plus and 2 electrons. Copper ions go into the solution. At cathode, reduction process takes place. That means copper with 2 plus ion will gain 2 electrons to get a pure copper. So copper ions deposit as the pure copper over there. So pure copper is deposited on the cathode, that you need to remember, and impurities settle down below the anode as anode mud, right? So this is a one method. And even if you go to the further, so we go for the questionnaires. So first one, define the following terms: mineral, ore and ganj. So mineral is a naturally occurring substance that contains a metal or its compound. Not all minerals are useful for extracting the metals. Example, bauxite, it contains aluminium, and hematite, it contains iron. So minerals are basically, they are naturally occurring substances that contain metal or its compounds. What is ore? Ore is a mineral from which a metal can be extracted easily and profitably. So all ores are minerals, but not all minerals are ores. Okay, example, bauxite is a ore of aluminium because aluminium can be extracted profitably from bauxite. Coming to ganj, it refers to the impurities like sand, soil, clay, etc. that are mixed with the ore. Ganj is removed during the process of concentration of the ore. Next, name two metals which are found in nature in the free state. Right, gold, silver, and platinum. They will exist in the pure form. They exist in free state because they are very poorly reactive metals. Right. Coming to third question, what chemical process is used for obtaining the metal from its oxide? So for you can get the metal from its oxide. How to get it is, you can use carbon or carbon monoxide. That is one condition. For example, ZnO, if you take zinc oxide, if you heat in the presence of carbon, it becomes zinc plus carbon monoxide. Similarly, if you have iron oxide, so then also you can use the similar method. Fe2O3 iron oxide plus carbon, it will form iron plus carbon monoxide. So this is one method. For less reactive metals like mercury, silver, then simply by heating procedure you can obtain the metal. For example, HgO is there, mercuric oxide. So directly by heating process you will get mercury together with oxygen. So this is the another method. For highly reactive metals like sodium, calcium, aluminium, they cannot be reduced by carbon. They are extracted by electrolysis of their molten salts. For example, electrolysis of molten aluminium oxide, Al2O3. If you do electrolysis for this one, what will happen? At cathode, you will get Al3 plus and 3 electrons will be released. And right, at anode, oxygen 2 and it will become half O2 plus 2 electrons will be released. So here you will get the aluminium at cathode. Like that you can use the electrolysis process to extract the metals. Thank you.